Hello APC Mechanics students, today we'll solve the past paper FRQ 2005 exercise 3. A system consists of a ball of mass m2 and a uniform rod of mass m1 and length d. The rod is attached to a horizontal frictionless table by a pivot point and initially rotates at an angular speed omega as shown above left. So it's frictionless, which means we can apply conservation of energy, and it's rotating at an angular speed omega. The rotational inertia of the rod about point P is 1 over 3 m1d square. The rod strikes the ball, then we have collision, which is initially at rest. So the ball is initially at rest, which means initially it doesn't possess any momentum. The momentum is only due to the rotating rod. As a result of this collision, the rod is stopped, so the rod will lose its momentum, and the ball moves in the direction shown above right. Express all answers in terms of m1, m2, omega, d, and fundamental constants. In part A, they're telling us to derive an expression for the angular momentum of the rod about point P before the collision. So we know that the angular momentum of a rigid body is given by I omega. So let me say that this is R for the rod. Now the moment of inertia about P is given by 1 over 3 m1d square. And omega is omega. And indeed, it's being expressed as required. Then the angular momentum of the rod before collision is given by 1 over 3 m1 d square multiplied by omega. Now in part B, derive an expression for the speed v of the ball after the collision. Therefore we need to use the conservation of angular momentum. Apply conservation of angular momentum. Which means initial angular momentum should be equal to final angular momentum. The initial angular momentum before collision is only due to the moving rod, which is given by this quantity. And after collision, the rod will lose its momentum, and the momentum will be gained by the mass m2. And what's the momentum of the mass m2 after collision? We're talking about angular momentum. It's given by its mass m2, its velocity v, and the distance from the pivot to the ball itself, which is d. So that would be the angular momentum of the ball m2 after collision. So m2v multiplied by d, and we're interested in finding v. Now d would cancel with the power 2. Then in this case, v is given by 1 over 3 the fractional mass m1 divided by m2 multiplied by d omega. Now in part C, they're telling us, assuming that this collision is elastic, calculate the numerical value of the ratio m1 over m2. Now we need to calculate the ratio m1 over m2, and they're mentioning that the collision is elastic, which means that the kinetic energy of the system before collision is equal to the kinetic energy of the system after collision. For this reason, I will say kinetic energy initial is equal to kinetic energy final, and here no need to mention any law. Now before collision, the energy is given by purely rotation by the rod, which is given by half I omega square. And after collision would be the kinetic energy of the ball, which is given by half the mass of the ball is m2, and its speed is given by v to the power of 2. Now the moment of inertia is given by, let me check, 1 over 3 m1d square. And omega will be kept as it is. That would be equal to half m2. And because v has been determined in terms of omega, so let's replace it. Now that would be 1 over 2 times 1 over 3 m1d square omega square is equal to 1 over 2 m2 times 1 over 9 m1 square m2 square d square omega square. Now d square cancels with d square as well for omega square, Now this would cancel with this, and m2 would cancel with the power 2, half would cancel with half, and 1 over 3 would cancel with 1 over 9, and here we have 1 over 3. So on the left we don't have anything that would be equal to 1, which is equal to 1 over 3 m1 over m2. So basically the ratio that we're searching for, m1 over m2, because they told us calculate the numerical value, would be equal to 3. Now for part D, a new ball with the same mass m1 as the rod is now placed a distance x from the pivot as shown above. Again, assuming the collision is elastic, for what value of x will the rod stop moving after hitting the ball? So we need to determine the value of x. Now, in order to do so, and because they are referring to the collision to be elastic, so for sure we need to use the conservation of the kinetic energy. But if you notice carefully, here we have used the conservation of kinetic energy, but the thing is that v, the speed of the ball after collision, was related to omega, and this have been achieved by using the conservation of angular momentum. So here, in order to solve for this problem, we need first to apply the conservation of angular momentum to find the speed of the ball m1 immediately after collision, and we use the expression for v in the conservation of kinetic energy in order to determine the value of x. So first let's proceed by applying the conservation of angular momentum, then apply conservation of angular momentum. So again we will say L initial is equal to L final. Now initially we have the same angular momentum of the rod, which is given by 1 over 3. m1 d square omega is equal to the final angular momentum, and here if we're assuming that we need to search for the value of x, will the rod stop moving after hitting the ball? So again we need to assume that the rod will stop after collision, so only the ball m1 will possess its momentum, so which means that would be m1 multiplied by the new speed, and I will name this to be v prime, multiplied by x, and we're interested in determining v prime. So in this case v prime, now m1 with m1 would cancel. Now v prime would be given by 1 over 3 d square divided by x multiplied by omega. Now here they didn't tell us to determine the numerical value of x, so we refer to the previous statement, which is given by, we need to express our answer in terms of m1, m2, omega, and d. And if you notice carefully that here in this case this is not an acceptable answer because we don't know what is v prime. Now in order to proceed we need to use the fact that the collision is elastic, which means kinetic energy initial is equal to kinetic energy final, and that would be half I omega square is equal to half m1 v prime square, which is half 1 over 3 m1 d square multiplied by omega square, which is equal to half m1 into 1 over 3 d square x omega square. So that would be half 1 over 3 m1 d square omega square is given by half m1 1 over 9 d to the power 4 x square omega square, and luckily omega square with omega square they cancel, half with half they cancel, m1 with m1 they cancel, 1 over 3 with 1 over 9 with left with again 1 over 3. So d square with, so let me do this here, we have d square equals to 1 over 3 d power 4 over x square, d square cancels with d power 4, that would become d square, then 1 equals to 1 over 3 d square over x square, and we're interested in determining x squared, then x squared would be 1 over 3d squared, and if you consider the square root, then x would be d divided by radical 3, and that is an acceptable answer. Why? Because they told us to express our answers as function of these, and indeed it's being expressed in terms of d. Then that's it for me in this video, guys. See you soon in a new one.